And we're back to Career Build Series, episode 203. And so we're back at home base here, where we left off. And so first thing let's do is look, see if we have any missions. I don't believe we do that are worth doing. We just have some transpos. We're not going to do those. Let's go ahead and we'll jump in the bed. We'll see what we can pop for some missions. We'll start with a mission. I'm really liking my lamps. Lamps are looking great. House is starting to come along. Nice having all of that. The bloom off the light's a little silly, though. Let's see. Got a bed. Oil rig. Fire. Let's see where that is. Alright, so if the oil gantry up there is on fire. So let's go ahead up there. Let's go ahead and take... I think at Katie. And so how to spawn Katie. Let's see. Kind of want to get some things in the world and get them working here too, so... let's try it this way. Let's do the barge. Sometimes this doesn't work. Sometimes I can get this to work, sometimes I can't. See, that would be edit vehicle and workbench. Yeah. Let's go ahead and take the Cormorant. I haven't taken the Cormorant in a while, and I'm kind of interested what that needs. So let's take that anyway. That'd be kind of fun to use. Playing a game here. The floor is lava. Oh, nope. Trying not to get wet, but didn't happen. So I'm curious how much diesel I have in this bench. So let's double check that. That is interesting to me. Okay, so we're able to fill our vehicle, so that's good. Nav lights, our beacon's coming on for an engine start. Let's go ahead and see if I can't remember how to start this. Master power, engine start. Turn the game volume up just a hair. I think I have a headset on my seat. All right. Just checking some things here, trying to make sure I have this all set up. Forget my prop settings. I did make a checklist for this. Let me bring that up off screen here. Did make a checklist. I need to start making checklists for all my craft, my aircraft especially. That will help with, especially like I often forget what they are. So pre-flight cockpit. So let's go through this checklist. Let's actually just bring the prop back to 0. I don't want to go in reverse. Okay, parking brake is on. Master power. Verify fuel. Check volts. Check battery. Okay, that's complete. Start checklist. Beacon on. Throttle idle. Engine start stop. Verify RPM and engine temp. So RPM, engine temp is good. All right. Check volts. All right, we'll check our voltmeter. Voltmeter is reading. It's not discharging. Taxi checklist. Release parking brake. So we're in the water. So we don't need to do that. We've already done that. So let's see. Test brakes, nav light. So we'll do nav light. All right, and then next thing we want to do is set course. So that's important to do just because when you take off, you don't want to have to get distracted and do that. So it prepares you for flight. Takeoff C, gyro on off. So we'll go ahead and because of the way that the I don't know if that actually works. Because of the way that this works, it's helpful to have that on for takeoff, and that's usually only when I run it. Flaps to takeoff. So let's go ahead and set flaps to 100%. Probably let's do 50% flaps. Strobes, landing lights. Strobes and landing lights. Gear up. So this is why I did it, just to make sure I don't forget things like my gear. Gear is verified up. Release parking brake. So we need to release the parking brake. Remember we had that crash landing. That's why I made a checklist. All right, good. So takeoff checklist is complete, so we're ready to take off. We're going to take off into the wind. Let's check my settings, make sure I don't have anything weird. Vehicle damage, all that's good. Let's go override weather off. Let's go override time off. Override wind direction is off. That's good. Alright, so we're good to take off. So wind is calm, so we'll just go straight ahead. I didn't put what the prop settings should be, so I should probably do that because I forget. Alright, so we're climbing positive rate. Gear up, gears up. Greater than 100 knots, we are flaps up. Landing light off. Okay, good. So cruise, set prop throttle. We're not in cruise yet, so the cruise checklist will come when we get to cruise. So I'm going to go ahead and I'm going to put in the waypoint. Go ahead and put in an altitude. Let's go 1,000 feet. Let's go ahead and we will turn on the autopilot and we will turn to course. We're turning. So this is IMC conditions. Instrument meteorological conditions. So IMC, you can't see outside. You need to use all your gauges. That's one of the reasons why it's important to set up when before you take off so that you are all prepared for flight. So that is normal for that to flip. The reason it was flipping was we were going from facing away from the waypoint, which of course it's going to just keep taking more time to going towards it. And now it was able to calculate a time. Alright, so I'm going to go ahead and increase my propeller. And so we'll go to a cruise. You know, I could, you know, generally on climb out, you'll do that. You go, in a complex aircraft you do mixture prop throttle all the way forward. And then prop all the way forward is actually low pitch, high RPM. And then as you take off on your climb, you tend to, you'll start to bring your prop back. Because you no longer need that that climb prop setting. All right, so we're there. We're in cruise. So let's set prop, set throttle. So I'm gonna go full. We'll go full prop. Do a nice efficient. You know what? I don't want to go this slow. Let's bring it back up. That's pretty good there. We'll go to 71 on the manifold pressure. All right, so time to waypoint is going to be 5.8. Let's go a little bit faster here. So we'll go about 40. Let's go about 45. Get the speed up a little bit here. All right, so I still haven't decided what I want for that monitor or if I want anything for that. It's kind of just a blank space. The reason it's there is because I can't have a panel here across this keypad, so that's there. So we're going to do this fire here. And we can actually, I'm going to move my waypoint up, stick it right out on top of it, because again, we're going to be flying over it. And time to waypoint's 4 minutes. So let's go ahead and get in the back and get ready for this. So what do I have on me? I need a Fire X. That's going to be on me. Alright, good. Let's see what else. Just kind of seeing what I need in here. I think we're pretty good on this aircraft. That's backup battery, buzzer. Okay, good. So I'll go through some of the more of the checklists. So descent, set throttle, approach to land, gear down, verify. This is approach, land. We're going to be doing approach C. Approach C is gear up, verify parking brake off, flap set for landing, landing light on, and then that's good to land. Then taxi, we have that procedure shut down. So. All right, we're currently 3 minutes out, so we're going to descend. Let's go down to 100 feet. And so we're going about 1,500 feet per minute. That's set with my PIDs Bishop was asking for a little bit of a tutorial for that, so I think I'll do that. You know, the question was, why do I have two PIDs? So essentially, let me just watch here. That's a cloud. So I have two PIDs running this autopilot system. The reason I do that is, I'll get into it more in that little... No, there's land. Okay. What are we at here? Set this to 300 feet. I don't want to go down anymore. We're in IMC. I'm not paying attention. See? That is dangerous. So, so we must be over the land here. Alright, that was my fault. I should have been checking my position. You know, one thing I wish we had is the ability to see our compass rose. So what I'd like for this map is the ability to drag. So like, say, click here and drag a line. And then you could see the compass heading and you could see the distance. Then we could actually plot courses. But, you know, again, I'm kind of an aviation weirdo. So, you know, most people probably wouldn't use it. So back to the autopilot. So Bishop was asking for kind of a little, was asking why I used dual PIDs. And so the first PID, essentially all that's doing is I put in my set altitude. So for this case, 300 feet. I was at 1,000 feet. So the PID's going to say, hey, that's way down there. Pitch really hard, you know, give me a lot of pitch down. I'm just watching the terrain as I go around. Let's go back, bump up to 500 feet. You know, normally you'd be traveling, like, say, you know, maybe not this short of a distance, like, say, like 5,000 feet. 1,000 is pattern altitude. You really wouldn't go lower than that until you verified your landing, but, you know, in game I'm going a little bit lower than I normally would. But anyway, so the first PID, because you're at 1,000, you want to go down to 300, it would give you a really strong pitch down, and then it would aggressively try to level you off as you get to your set altitude of, say, 300 feet. And so that's fine. That's going to give me a number. It's going to give me a large number, and then it's going to give me a small number. That's all fine. The second PID's job is to set my vertical speed. And this is how we'd actually do it in the airlines was, let me check time. Okay, so that we're coming up on it now. It's going to be tough to see. We see the... Right now I see the, most likely the beacon off the Coast Guard beginner base, which I think... Yep. That's it right there. You can see the beacon. Alright, so what I'm going to do here is I'm going to go down. We are over the sea. Let's go down to 100 feet. I'm actually going to make this... I don't want this right on the oil rig. Let's put it there. I want to fly by the oil rig. I don't want to fly into the oil rig. And so that's going to give us a big pitch change. And so we used to do this in the airlines. There was something called flight level change, and it was pretty terrible. It essentially worked like that first PID. If you had a lot of... Oh, what's that? Just water. If you had a lot of altitude difference, it would really aggressively push the nose down, unsettle all the passengers, do all that stuff, and be generally a pain. Alright, so this is going to be hairy here just a little bit. I need to be very careful here. I need to watch my altitude. I'm going to fly like an instrument pilot here. So I need to be very careful of my altitude. I need to monitor my heading. I need to cross-check my gauges. So I'm going to go, I need to bring my prop back while I'm doing all this. Whoa, 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 whoa. Okay. I don't know what was up with that. Alright, that was ugly. Me flying in IMC, not paying attention enough. I was paying attention, but I'm trying to do my prop, and like I couldn't see it at the same time that I was working. So one of the things I, you know, did a stream with Endo and crew, and so one of the feature requests I had was track IR. And I really want track IR because, like, one of the issues, you know, the main issue that caused me problems right there was I couldn't move where I was looking while I was flying. And so I want to be able to move where I'm looking while I'm flying. And so let's put the flaps down. Alright, I'm trying to... Where's the ADF? ADF direction of waypoint. Alright, so see this needle over here to this one here. Let's use that needle to get back on course here. So I'm very cautious about my altitude. Like right now, Trying to roll out. We're dropping like a stone here, so I need to be careful. I have full flaps in. Full flaps, I really shouldn't be doing very big bank angles. So I passed it. I'm trying to get back to course here. So I want to get that center needle. See, like I have to pay attention. Like you really have your head in the cockpit while you're in IMC like this. So if you look at that center needle on my right, that is centered up now. We're way high. There it is right there. So I'm just gonna kind of, so see like that, I would be using the track IR to move my head. I don't have that, of course, and I wish I did because I could very easily look left and watch it, you know, for reference. I can't do that. Like, see, I want to be looking left again. I can't. So let's taxi over there. Alright, I'm trying to get my throttle down, but I keep smashing the wrong key on my keyboard while I'm doing it too. So not the most graceful, but you know, like I said, I need track IR because you underestimate how often you need to look left, check your point. You're constantly moving your head around, and I have to use my mouse while my throttle's on my right hand, so I have to take my hand off the keyboard to do that. So I would really like track IR. I wonder if there's some way I could make it work. I have track IR. Like, especially if I'm flying a flying game, I am constantly, like, you'll see check a gauge. Like, so you call it a cross-check. So as I was flying there, I need to cross-check my altitude, back outside. Airspeed, back outside. Attitude, back outside. ADF, back outside. Altitude, back outside. And that's what you would do IRL. You're constantly like this. This is what it looks like. And it's very natural with track IR. You'd be like this, and you'd be good. It's more difficult in the game because I have to literally take my hand off the controls to then go over and reach for my mouse and do that. And it makes it very difficult for me. So, you know, that's a feature that I would like. Alright, so we're here. Let's go ahead and, let's see. Taxi, landing lights off, strobes are off, flaps are up. Shutdown, throttle idle, it is. Prop feather to 0. And all of this is so that we can restart this. It's all configured in the proper way here. Okay, that's fine. That's close enough. Set parking brake. Of course, we don't need that in the water. We'll put it on because it's on the next checklist anyway. Engine start stop. Nav off, beacon off, interior light off. So we're gonna keep the we'll keep our beacon and our nav lights on just because we're sitting in the water here, and we'll leave the master on to power that. That's fine. All right, so we're out. Let's go ahead and put this fire out. Again, not the most graceful of approach, but you know, track IR would make it much easier. If you saw my altitude, you know, as far as the regs are concerned, you get plus or minus 300 feet of your altitude, of, you know, what altitude you should be at, and I was all over on that, and part of it was I kept having to take my, you know, kept having to take my hand over the mouse just to get a look going, so, you know, somebody had mentioned, you know, I play VTOL VR too. It would be nice to get back into VTOL and do a video on that, because that has, with the VR headset, I can, fly much more naturally. If I'm, you know, when I make a video on that, you'll see like I'm constantly looking around, and it's much more natural because you're just looking. You're not having to, you know, take your hand off to move the mouse. Bingo. Okay, there's 300. Let's check this. Remember, there's a new save, so we're going to check it for crate. Then I don't know if it said, are there people here? Okay, so there are people for rescue. You look like you're not wearing a shirt. I hope, what's going on there? Are you wearing a shirt? Okay. Maybe it burned off in the fire. I don't know. Listen, stop. Listen, Miss Nude, stop following me. Stay, please. Okay. Got a stalker. You guys need rescue. Okay, good. Okay, good. But, we've saved them. Let's go rescue them. I didn't want to say that. Oh, there we go. Good. Cash, money, dollar bills. Good, good, good. All right. Any more cash, money, dollar bills? Have you seen any? Hi. Pleased to meet you. Let's check the thing, see how many we have. 2. Okay, so those are our 2 Johnnies that need to be rescued. All right, can you guys help me out here and do... Hiya! There we go. So let's swim. All right, let's go ahead and get in the Cormorant and get out of here. So I'm going to try to get these people not to act the fool here. And so you stop following. You stop following. Pick you up. I'm trying to hiya in here. There we go. All right. Seat. There. How's your health? You're full. You're the full health. The one with no shirt on has the has less health. Probably because the health was in the shirt. Oh, come on. Here we go. Get in there, you. Take that. Take that. Jump in there. All right. Let's get getting. All right. So it's kind of nice to fly an IMC a little bit here. It's a little bit of a challenge. Just gonna go right here. Again, this is tough in IMC. Actually, where is the military hospital? This hospital ship. Where is the military hospital island? Right here. I want to go here. I want to do a landing at an airport, especially in these conditions. All right, so we want to reverse our checklist. So parking brake on, master power on, verify fuel, bolts and battery, pre-flight's complete, start checklist, beacon on, it is, throttle idle, engine start stop. We'll verify RPM and engine temp. RPM's good, engine temp is still good. Check volts, volts are good. Okay, text checklist, release parking brake, test brakes, nav light, set course. Okay, so set course. Set course. Okay, good. We'll also set our altitude. So we want 1,000 feet. Okay, next thing we want to do is we want to set our heading. So we want to go to our current heading, which is 9.5. 9.5. We want to take this off. Okay. Put the gyro on for. I'll do it via the checklist. I don't want to get ahead of myself. Taxi. Okay, so taxi checklist complete. Takeoff checklist. C. Gyro on off. That's again at our discretion. If it says on off like that, that means it's at your discretion. Flaps to takeoff. We'll go to 50% flaps. All right. Landing light. Strobes. Gear up. Gear is up. Okay. And release parking brake. All right, good. So we're good to go here. So wind is calm. We'll go straight ahead. So I need to add set prop. I did not have set prop on there, so that should be on my checklist. All right, we are up. So now the reason why I set all that in is you see how I can instantly put my autopilot on? By putting in all my stuff, my heading, my altitude, I can do that. It lets me, so you do that at IMC at 200 feet. And so the reason is now I can look back at my checklist and I can go into climb. Positive rate, gear up. Gear is already up. Greater than 100 knots, we are. Flaps are coming up. Landing lights off. So the whole point of an autopilot, it's not to actually do everything for you. It's workload reduction. There's still plenty of work to be done. It's supposed to be for workload reduction. All right, now let's go on course. We'll go heading, hold to bearing. I wish these runways were numbered properly, so they're based on the compasses, and I wish they'd write them on there. That way I know I can put in a heading so I can tell where I'm going. All right, so we'll wait till that stabilizes. We're at 1,000 feet. We're doing 65 knots. Let's go ahead and we'll put in prop to about 40. 45 rather. Alright, cruise, set prop, set throttle. We're good on that. Cruise checklist complete. So next checklist will be descent. Alright, let's check our distance. Time to waypoint's 4 minutes. Distance is 11 nautical miles. So we descend in this aircraft, you know, to get back to the PIDs. So the first PID is doing what the flight level change does. Is it's kind of giving you that messy PID altitude change where it quickly throws your nose down, then it quickly tries to bring your nose back up. And it's just kind of all over the place, and it's ugly. And you imagine if you're a passenger and you're 50 feet behind the center of gravity and the center of lift, you're going to be thrown up and out of your chair. You're going to go weightless. You're going to slam down in your chair. It's going to be miserable. So what we would do is when we would change altitude in the airlines, we would go by, you'd set your vertical speed. And so you change your altitude, say down, you want to descend down to 500 feet. And you'd set your vertical speed to, since it'll be only 500 feet, we'd set it to 1,000 feet per minute. So what the second PID is doing is it has a maximum allowance of 1,500 feet per minute. That's what I said in there. And so what it does is when the first PID says, hey, give me a lot of descent, it says, okay, I'll give you 1,500. Because that's the most it can give you. If the first PID says, hey, give me a little bit of descent, it says, okay, I can give you up to 1,500. It might give you 800. So what it's essentially doing is it's limiting the amount of vertical speed to a normal, reasonable vertical speed, and that's why it smoothly goes. And even if I have to descend 10,000 feet per minute, it will give me 1,500 feet per minute because that's a reasonable descent rate. All right, we're 2 minutes out, so let's go ahead. We're going to go 1,500 feet per minute. We only need to go 500 feet, so it'll be a third of a minute. So we're talking 20 seconds down to 500 feet. You know, this is, you know, when you fly a lot, this is when your mental arithmetic gets really quick because you have to do things like step descents where you're trying to determine how many your vertical speed settings. So, like, we had one big step descent down into New Jersey, into Newark. And we were late. We were late starting, and ATC calls and say, "Are you going to be able to make the descent?" Well, I could, you know, I looked back at the captain and go, and he looked and he's like, "Are you going to be able to make it?" And I go, "Yeah, no problem." And so, and it was because you can really quickly figure out your descent rate. And so, let's check time. 1 minute. Okay. So I'm just kind of saying where we should be. We should be coming over this area here probably. I think we just passed some land, so we're probably coming here. So let's go down to 200 feet. 200 feet is, on a non-precision approach, is going to be our decision altitude. So I need to see this at 200 feet to make the decision if I'm going to land. So here we go, right where I thought. We're going to be right by the bridge. All right, so anyway, so you get quick with your mental arithmetic on knowing how many feet per minute you need, how fast you're going. So right now we're going over 2 miles a minute. So we're going about 2.5 miles per minute. So if we're going 2.5 miles per minute, we need to do 2,000 feet. You can quickly do that in your head and get going. So we're down to 200 feet. This is our decision altitude on our non-precision approach. Let's get prepared. We need a set prop, set throttle for descent. That's fine. Go to 30. Okay. Gear down. I really need to do this quickly. Gear down. Verify parking brake off. Flap set for landing. Landing light is on. Okay, I need to do this very quick. We have very little time. So as soon as I decide that I can see the airport and I'm going to land, I need to boot the autopilot off and I need to take over. And so this is how you do it in real life. On a non-precision approach, we come down, we level off at an altitude, and we look for airport in sight, continuing. All right, there it is there. We missed it. All right, that's fine because I didn't set up for it properly. All right, so let's do this. Let's put the autopilot back on. Let me set this up as a real instrument approach, okay? I think some of you guys might find this interesting. So let's go ahead and let's put the gyro back on. Why is my altitude 200 feet? Okay, it's descending to 200 feet. Okay, so let me set this up as a real instrument approach. So let me do this. So let me trying to get this. Let me get this waypoint out of here. Remove waypoint. Let's go ahead and let's go print screen. Let me let's pause this and kill the sound. All right, so let me show you how I'm going to make an actual instrument approach. And so you guys might find that interesting. Let me see. All right, so I will make us an instrument approach. Let me just, I'm trying to get it configured in Paint so that it's all set up, and then we'll do that. So I'm going to make us a real instrument approach. I think this will be nice to be able to do here. All right, so once I get this copied and on a new screen, I'll switch you guys over so you can see it. All right, so we're going to make an instrument approach. So we came in here, so this is the runway we want to land on. I don't know the heading of this, but I don't really need it. So you have a couple types of approaches, but for the two main types are you have precision and non-precision approach. And so let's first talk about a precision approach. So a precision approach is an ILS, instrument landing system. And so the way an ILS works is you have two components to your ILS. You have the localizer and you have the glide slope. So the localizer, it's actually a little tower, a little building right here at the opposite end of the runway. So we're going to come in, we're going to land this direction. So your localizer building is right here. And so the localizer draws a path right down the runway like that. That's your localizer. All right, and so what you do is, let's say we're coming in, you'd come in at that's less than 45, but let's say you're coming in like this, and the needle would start to come in. As the needle comes in, once the needle starts to come straight, you'd start heading your course, and you'd maintain the needle. If the needle goes off to the right, that means you're off to the left of the course. You'd come back. If the needle's off to the left, you'd come back. That allows you to maintain course. You also have a glide slope element. So the glide slope is actually right here. It's a shack at the close end of the runway, and it puts a course up. It's a 3-degree glide slope, so it's like a cone, so it'd be like this. And so if you go above the glide slope, the line would be below you, so you need to come back down in the cone. So you're flying down into the cone the whole time. If you go above it, the needle will be below you. If you go below it, the needle is above you. As you get closer, it gets more precise. So that's a precision approach. That will bring you all the way down to the runway. That will get you down to 100 feet. At 100 feet, you can determine whether you're going to land or if you need to go around and go somewhere else. What we're going to do is a non-precision approach. Non-precision approach is a little bit different. So a non-precision approach, again, it's not as precise. So you don't have a glide slope, and you don't have a localizer. What you'll often have is GPS stuff. It simulates that, but like a VOR would be on the field, so you can find the field, and then you need to be able to see the airport to land. And so what that would do is give you a radial. So let's say the VOR is right here off the right side of the runway. It would give you a radial like this. So it's not perfect. Let's undo that. It's not perfect. It's off the side of the runway like that. All right. And now, so let's imagine this, try to find this. So let's imagine we're looking at this. This is a side view of our landing. So we have the airport is right here. Okay, that's the airport. And so on a precision approach, when we were talking about it, you have your localizer, right? Your localizer is essentially just drawing a line out. And then you have your glide slope. And so this is looking at the side. This is a side view. So your glide slope is at 3 degrees, and it makes a cone like this. And so we would come in, tracking the localizer. And then when we notice our glide slope, we'd say glide slope alive when the needle starts moving. And then as we come in, we essentially follow that glide slope all the way down, and we land. That's a precision approach. We're not going to do a precision approach. We're going to do a non-precision approach. And so what you tend to do is you have step descents. And so what you would do is you'd come in here, and we have our course, right? We have our course needle, right, our course line right there. So let's make our course line. And let me do a different color. Let me do, we'll go ahead and we'll do green. And, oh, no. Get out of there, you. Okay, let's do green. And so we have green. And green is going to be our vertical component. Now, remember, with that precision approach, it literally brings you all the way down into the ground. If you followed that glide slope all the way down, you would go in and you would hit the building. You'd hit the glide slope building because it's bringing you right to that tiny little building sitting at the end of this end of the runway. The localizer is on this end of the runway. So it would literally bring you all the way down. Now, a non-precision approach doesn't do that. Now, if you remember, we leveled off at 200 feet. So right here, let's say that's 200 feet. So that's our level off point. Now, you know, there are certain laws in place that you can only put certain objects of certain height, a certain distance from the airport, and they can't be on the approach path. So you couldn't put a 2,000 foot tall building right here on the end of a runway. Legally, you can't do that, but you could put it over here, and that lets you go next to it, but not run into it. And so, but out here, you might have a 2,000 foot tall building. So what you do is you get, on these non-precision approaches, you have these steps. And so let's say you have another step. So let's say you don't have a 2,000 foot building, but you have some 500 foot obstacles. Let's say a building or radio antennas or anything like that. They'd be right here. So and then let's say you have that 2,000 foot tall building right here. And so that 2,000 foot tall building would be right here. And so for a non-precision approach, it looks like often steps. So remember the precision approach looked like you had that cone and it brought you down nice and smooth. This is steps. And now what we can do is we can actually, I can't really cut it on this one. Like if this was expanded out, like what I can actually do, like, you know, you don't have to do a step climb. You could actually make yourself a nice smooth descent like this. By, again, doing that quick mental arithmetic, you can actually come down. And as long as you don't break through these hard lines, you can come down like that, but that just takes planning. So what you do in a non-precision approach is, let's say out here, because we have that 2,000 foot tall building, we need to come, this is 2,500 feet. So you're required to be down to 25, can't see that at all, can you? 2,500 feet there. Let's say this is 1,000 feet there, and this is 200 feet there. So this would be a non-precision approach. So, and the way you would measure this is with DME, distance measuring equipment. So that VOR there has DME. So right here, that would be at 0 DME. That's at the building. Right here, let's say that is at 1.5 miles. Let's say this is at 2.5 miles. And let's say this is at 4 miles. So at 4 miles, I want to be down at 2,500 feet. So I would get on course. I'd be coming in like this. And then right here, I want to be at 2,500 feet. So this is the overhead view. This is the side view. So as I come in with my plane, I would descend down. And within 4 miles, I want to be at 2,500 feet. Once I hit 2.5 miles from the airport, I want to descend from 2,500 down to 1,000. Once I hit 1.5, I want to ascend from 1,000 down to 200. And then I want to take 200 in all the way till I get to the airport. And so that's that. Let me see if I can find you a VOR approach. Okay, so VOR approach. So this is what a VOR approach plate looks like. So this is the VOR runway 35 left at Grand Forks International, GFK. So this is your frequency. Frequency is 114.3, channel 90, approach course 344. So when we look at the approach course, if we look back at my wonderful drawing, 344 would be this approach course here. So you know how to set in your dial to give you that. All right. So next thing we have is runway landing. This is how long the runway is, 7,351 feet. Touchdown zone, 845 foot touchdown zone. Airport elevation is 845 feet. So that's important. Remember, your altimeter is reading the height from sea level. You change your altimeter setting based on the pressure altitude at the airport. So you would listen to the ATIS, the airport advisory frequency. If we see right here, ATIS 119.4, so we'd switch to 119.4. We'd listen to it. It would say, you know, altimeter setting 299.92. That is standard. You put that in. So when you get, so as you're coming down, you would be touching down at the airport at 845 feet. Approach altitude for non-jets would, or pattern altitude for non-jets would be 1,000 feet above that. So 1,845 feet would be pattern altitude. For jets, usually it's 2,000 feet, so it'd be 2,845 feet. We're not going to go through that. Malisar is the type of lighting that the runway has. If you see it as a visual representation of what that looks like. Missed approach. This is if you get to the airport, you follow procedures, you cannot see the airport. You would want to climb to 1,300 feet, then climb to 3,600 via the GFK radial 360, then a right turn direct to the GFK VOR and hold. So what that would look like is very simple. This is actually depicting that. So this is our approach. This is our missed approach. So if we came into the airport and we didn't see the airport, we have to go missed. And so, for example, the only reason you would stay here is, let's say, so this is 3-5 left. This is the one we're going into here. Let's say that 9 left had an ILS. That's unlikely that the shorter runway would have an ILS, but ILS would allow you to get lower. And so what you do is, let's say you're coming in on 3-5 left. You come around, you miss the approach. You say, hey, can we get 9 left? Well, the ILS for 9 left. You come in at 9 left, and you're able to get down to 100 feet, and you could see it. You land. All right, but you come missed. You'd spin your VOR to, you'd essentially turn your knob till you get 360. You'd follow that radial out. You would climb to 1,300, then 3,600 once you get on this radial. So you go to 1,300. That keeps you from hitting anything. Then once you get on this radial, you need to go to 3,600. That could be putting you over a building, so you want to make sure you get up to 3,600 feet. Then you want to take a right turn, and you want to go directly back to that VOR, the airport. So you'd spin the knob till it straightens up. You'd head right back. All right, that's the approach frequency. That's the tower frequency, ground frequency. That's clearance. That's the Unicom frequency. So see right here, we have this little chevron. That's 1,474 feet. That's a tower or an obstacle. Right here, we have a 930-foot obstacle. We have a 1,326-foot obstacle. We have a 1,050-foot obstacle. Now, notice this radial. This is how we approach. So I bet you that we have to stay above 1,050 feet because we're going to be approaching over this tower. And so we need to stay over that, that height. So right here, this is the frequency for, if you keep seeing here, it says GFK VOR DME. This is the Grand Forks GFK VOR right here. So that's on channel 114.3. So you put that in your navigation radio. And then what you do is you get Morse codes. You put in 114.3. Then you turn on the volume and you listen for Morse code. It would go beep, 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 beep. Or no, it would go beep, beep. And so that's, and you listen for that. And if the Morse code is correct, you know that's the right VOR and you're on the right frequency. See what else we have here. So, so this is that. This is a top-down view. So you'd come in here, and you would go. I'm trying to see what the approach is on that. There must be a radial off of this. GFK. I'm curious what this is coming off of. I'd have to look. But anyway, so you'd come in over here, and then you would join the 344 radial. So you would you put in this frequency. You would put 344 in your VOR. As the needle comes in, you would follow 344 in. All right, and so this is an airport diagram: elevation, touchdown zone, elevation. These are your runways. You have you have 9 left, 27 right. 9 left, 27 right there. If you look right there, 7,351 feet. It's 150 feet wide. That's a 4,206-foot runway by 100 feet wide. 3,300 by 60, 3,901 by 75. A bunch of buildings and what's nots. That's the visual depiction of what your approach lights look like, so you know what to look for. That's all taxiways in there. Let's see what else we have. This is your descent profile. This is how you descend. So if we look back at my picture here, that's what this descent profile looks like there. So you would come into the Grand Forks VOR DME. You go outbound. So you come in, then you go outbound on. So you come in like, let's say you're coming in over here. You come in over here. You'd hit the VOR, and then you'd go out on a 164 radial. So you're coming out on a 164 radial like this. You'd want to descend down to 2,500 feet. Again, this is keeping you over this, above this tower of 1,050 feet. So you'd come out on a 164 radial. You'd then make a left turn, and you'd come back in on a. This is a heading. See the R is radial, coming off of the VOR. That in degrees, that's a heading. So you'd come over here. You'd do a left turn, and you'd come in at a 299 heading. All right, and so you come in at a 299 heading. All right, let's see. You want to remain within 10 nautical miles. That keeps you safe from obstacles. Let me see where my... Okay, so once you come back in, so you come in, right? You're on your 119 heading back in. Once you get on the 344 course, you're allowed to descend from 2,500 feet down to 1,360 feet. Now, the reason for that is we have to stay up here at 2,500 feet to make sure we clear this tower. Once we get on this 344 radial, notice no towers on our approach path. That's a legal requirement. You can't have approach towers on the approach path. So like, you know, AT&T couldn't build a tower here. They'd tell them, no, you have to build it over here or over here. You can't build it on the approach path. So you come over 119. Once you get on the 344 radial, you're allowed to descend down to 1,360 feet. You want to be at that 1,360 feet at 2.4 DME, so 2.4 miles from here. That's a 3.01 degree descent rate. So right there, again, that's 1.4 nautical miles. Once you get in here, so you're going to descend down. What is my decision altitude? I'm a little rusty on this, so I'm trying to decide here. Trying to see where I'm at. I think it's keeping us at 1,000. Yeah, it's keeping us at 1,360 feet. So that's the altitude we have to stay at, 1,360 feet. And so if the airport elevation is 845, you're talking 500 feet. So we're going to be our lowest altitude we're able to go on this approach is about 500 feet. All right, 515 right there. So I did it quickly in my head, but 515. So 515 is we're going to be 515 feet above the ground. Now, on the approach we just did in the Cormorant, the only way I could see the runway was at 200 feet. We wouldn't see the runway. We'd have to go somewhere else. All right, so that's just kind of showing you that. So we're going to make a quick little, I hope you guys found that interesting. We're going to make a quick little approach here. So let's make, I'm trying to think how I could do this. All right, so we're over here somewhere. So let's do this. Essentially what I'm doing is, the problem is I'm making this more of an ADF, not a VOR. Sky made a, Jan made, same person, made a VOR. So maybe I'll install that at some point on one of my vehicles and actually make some VOR approaches. But we're doing an ADF, so this is a little bit different. So what I'm going to do here is I have to run the needle backwards. So we're going to do this as an ADF approach. ADF approach, let me see if I can find ADF approach. Trying to find ADF approach plate. So ADF is the old school way to do things. All right, ADF approach plate. Let's just find one. This might be New Smyrna. New Smyrna. Let me find the New Smyrna. New Smyrna is where I, you know, that's the actual airport where I did some of my flight training with the ADF. I actually worked at this place. Saudi Arabia. That doesn't help me. Let's see. I'm trying to find New Smyrna. ADF approach plate. Is EVB New Smyrna? I think EVB is New Smyrna. Okay, it wants me to buy it. It's nonsense. Anyways, so the issue with an ADF is, like, if you saw on that other approach plate, I could set a radial. It's going to keep that radial. I can't do that. So what I need to do is, it's going to be tough too because the wind's calm. So what I'm going to do here is I'm over here. So what I'm going to do is I'm going to, so let's say I'm here. I'm going to turn around like this. And I'm going to come in and I'm going to go straight to the waypoint. And so I'm going to put the waypoint right at the center of the runway. Then I want to go out on a, I don't know. See, I don't know the heading of this runway. That's part of the problem, is I need to know the heading of this runway. I should fly around and check all the headings of the runways. So let's go straight to it, and then I'm going to try to go out on the heading of the runway. And so essentially, I'll put the needle behind me, and I'll try to keep it on that. That's going to be very difficult. And I'm going to head out like this. And then I'm going to turn around, and I'm going to try to go in on a course of the heading. And so this is going to be a little ugly. I will try to figure out what these headings are on these runways. I'll try to make some approach plates. I think that'll be fun. Fun for me, let's say. All right, so let's go ahead. Let's turn the volume back up. Let's go ahead, and I want to put a mark on the middle of the runway. Let's go ahead and enter that in. Let's go ahead, and we're following that now. Okay, we're at 260 feet. Let's keep it at 200 feet. At 200 feet, I can just barely see the airport. Imagine this at night now. So this would be a very easy piece of cake. Maybe I'll talk to Jan and see if he's thought of doing ILS. I don't know. He might have played with ILS a little bit. That would be cool. All right, so see, we're starting to level out here. I want that. This should be straightening up. Once that straightens up, where are we going here? Let's start slowing down here. No point in me screaming around here. Going slower is going to help. So, all right, we're turning. We're just turning slowly. That's one reason I slowed down. Okay, so see, the needle is straight ahead. All right. So I want to go 325 heading, because I want to get this this off there. We're wallowing because we have full flaps, and let's take the flaps out. Once the flaps are out, because our ailerons they're flaperons. Oh, what's up with my altitude? Okay, took the flaps out. That fixed it. It's causing me too much drag. All right, so we're going back to the airport. Let's actually go straight to it for now. Okay. So I need to pause this here in a second. So let's go ahead. What do we at? 350, 350. I have to do this very fast. All right. All right, so that's right off of there. Let's go ahead to a, let's get rid of you. There's a lot of guesswork on my part. Say a 310 heading. Trying to figure out the heading of that runway. So what I'll do is, off screen, is I will fly around and I will actively try to figure out the approach headings of all the runways, and I will make some approach plates and approach procedures for the different runways. And so maybe next video what I'll do is I will I'll make that a video. We'll go through and we'll do that. All right, so we want to use our distance measuring equipment. We want to get far enough away from this runway that I can set up. So right now we want to look at our distance. We're only about, let's get out to 2.5 miles. And so I'm going out on a 310 heading. So this is showing me the airport's off my right quarter there. So let's do this. Let's help myself a little bit. So we're at 56% fog. Let's go to 40% fog. So take off that. That will give me more visibility. That will help considerably. Let's slow down here. Okay. Let's go out to 2 miles, 2.5 miles. Okay, so now what I want to do is let's enter in that waypoint. Let's go directly to it. Let's do some stuff off screen here while marking. I forget my heading reciprocals, so I need to do a calculator. So 310, so 130 is going to be the opposite. Watch my altitude, watch my altitude, watch my altitude. Okay. Didn't like that. So let's go 50% flaps. Yep, see it balloon me, the flaps push me up. So, gear down. Gear down. Parking brake is off. Up, come on, gear down. Don't have, up, I'm hitting the wrong things here. Okay, I don't have a lot of time to play around here. I need to drop some flaps or else it's going to waggle me the whole way because it's using the flaps and the ailerons for the same thing. So we're coming in on a 1716 heading. That's not terrible, but this should bring us in the airport. And what I'm going to try to do is, okay, I see the airport. Okay, autopilot's coming off. I'm going to hand fly it. I see the runway. We're going to continue. That's a term used as continuing. Gyro's coming off. I don't want that friggin' gyro on. Fighting me the whole time. All right, runway is in sight. Continuing. Perfect. We're right on the money, dude. So by taking 50% of that out, the what do you call it, out the fog too, that helped. And then you say landing when you intend to land. So landing. Look at that. All right. And I'm going to try not to crash into something. Why am I... What is up? Are my brakes on? No, my brakes aren't on. It's just being a little bit wonky. Oh! Okay, good. My wheels... What the hell's going on here, man? What the hell is going on here, man? Okay. Get out of there. Dickhead. Sorry. That person was causing me problems there. Come on. Get the friggin' in there, fire extinguisher. So the landing was fine. It was taxiing on the ground was causing me problems. Jeez. Taking it out on my passengers, too. They're already injured. They've already been through a fire, and I'm yelling at them. All right, so the approach worked well. The landing was fine. Ugh, you're going to need health, too. First, you're not even wearing a shirt. You're bugging me. Don't look at me like that. Sit in your seat. Passenger. Getting involved with me. Yeah. Fire extinguish the two of you. I blame the two of you for that. So that was all taxiing. It was me in third person wasn't helpful. Plus, I think I didn't yank the thrust back enough, and so because I didn't yank the thrust back enough, it was, you know, I was trying to do a high-speed taxi. I should have just taken my time. But, all right, let's get these ding-dongs rescued here. So I think that's what we'll do next video. I'll make up some approaches for these different airports. So I think that'll be nice. You know, once I came up with a procedure and an instrument approach for this, you see how we can make it in. It helped to cut the fog down just a hair, but, you know, still could have probably made it in. I wasn't sure I was going to get the approach path because I came up with that 310 heading by eyeballing it over my left shoulder when we came in. All right, where's Shirtless Magoo here? Yeah, this is moving still, so. Alright. What is something still broken here? I can't shut my engine up. There we go. Okay. Alright, come on, Shirtless Magoo. Let me out. Let me out. Let me out. Let me out. I think it's the relay is screwed up. The power relay. You following? Come on, ding dong. Yeah, so see this lip here? I got caught on this lip. And that's one of the main things that caused me problems. And then I gave it too much power trying to get up over the lip, so as soon as I broke free, it caused me to careen into the hangar. So, but yeah, I think that'll be fun making up some actual instrument approaches for these different airports because it's tough. And so an ADF approach is one of the hardest approaches to do. You know, it's the oldest, and it's really just, you know, it's the oldest type of approach, and it's very imprecise as far as precision approaches. You ding dong. Take fire. Why'd you stop following me, guy? But yeah, so I think I'll make some instrument approaches next one. ADF's kind of ugly. Could use Sky's VOR to make better approaches, but I think I'll come up with that next video. So I enjoyed that. It was nice to fly around in instrument conditions a little bit. I just need to come up with some procedures, get this going. So let's do this really quick. I don't have a compass. I'll do this in the next video, but I'll set the runway headings and I'll make some approaches. That'll be helpful. And most of them will be straight in approaches. They'll be easy that way. What do you cost? 90 grand. What are we at for money here? Okay. So I bought this place. And you still need to repair something. There's still the relay here is screwy. There we go. I'm out. Urgh. So I might have issues with this. All right, so I think we'll end it there. So that was fun doing an instrument approach. It was fun getting into some instrument conditions. Next video, we'll go ahead and I'll make some approaches. So I will see you guys in the next one.